All right, you guys, now let's work on defining functions. So I'm going to actually slide this over so we have more room to work with here. So the basic idea is we've got 6 functions that are required, okay? The first one is get a random word. So if we take in a list, it returns one random element from that list. Okay, so the first thing is we need some random. So up here, let's import random. Okay, if you wanted, you could just do a single function from it. I'm just going to import the whole random library. Now here, the most basic thing, right? If you were, or not even the most basic, the most advanced is you could just say return random.choice from whole word bank local. So that is the function from random that chooses a random thing from a list. I'm having you create this yourself, so let's not use that. Instead, let's do it ourselves. So the first thing we need to do is say, to pick a random thing from the list, we're really picking a random number. We're really picking a random slot number out of the list. So we're going to say random slot equals random.randint, and then we just need to pick out a starting number and a stopping number. And then all we'll do is we will return from this incoming list, we will return that random slot. So all we need to do now that we're saying pick a random number in the right range and then return the item in that slot number, now we just need to figure out the start and the stop. Well, the start's easy, right? Every list starts at 0. Now the problem is, what's the index of the last element? So I'm going to go last slot, and that's equal to the length of that list, but then minus 1. So if we have an element, or if we have a list that's too long, we start counting at 0, not 1. So 0, 1, there is no slot 2 in a 2-element list. The last slot is always 2 elements minus 1, is number 1 is the last slot, 0, 1. Right? If there's 3 elements, there is no slot 3. It's 0, 1, 2. So the last slot is length of 3 minus 1, which is slot 2, 0, 1, 2. So however many slots there are, you take the length and you minus 1. Okay, so that's the last slot. So then what I'm going to do is go down here. I'm going to go, the random slot is anywhere between 0 and the last slot, and then return it. All right, so again, you could make that shorter, more elegant, but I think that's much more clear. We're figuring out the last slot number. Then we're choosing a random number between 0, which is the first slot, and that last slot number. And then we're going to return the actual item that's in that slot number. Okay, so now check completed. So check completed is taking in a list that comes in as asterisks, right? So you've got all these stars here, these asterisks here, and you're saying, like, have they guessed every letter? Right at the beginning, no, there's just a bunch of asterisks. But eventually you start filling in, oh, there was an N, there was a P, there was an A, and eventually there's no more asterisks. So to do this, you could really quickly go something like return, is there an asterisk? Whoops, that's an 8. Is there an asterisk in this incoming list, right? It actually be the Boolean, the opposite of this. So if there's a star in the list, then the game is not over and you want to return false. So actually you'd write not. So that would be the one-line version. You would say, is there an asterisk in this, true or false? But it's the opposite. If there's an asterisk, the game isn't over. And if there is not an asterisk, then you want to say the game is over. So the true false is swapped. That's for the not there. That switches the Boolean true false to the opposite. Okay, but we're going to do it in a slightly longer version. We're going to say, okay, we want to search through our Hangman word local. So do we need the slot number? Are we going to make a change? No, we don't need the slot number. So we can use a for loop to just iterate over it. So I'm going to say for item in, whoops, that's in me. So for item in our list, so I'm cycling through the values in the list. So if it's a list of words, I'm cycling through the first word, then the next time the for loop runs, the second word, then the third. But I don't know the slot number, but it doesn't matter because I'm not using the slot number here. All I want to say is, if the item I come across is equal to an asterisk, right? So if I do find an asterisk, then stop the search. I know the answer. Is the game over? No. There's still letters to be guessed. So I want to right away stop the entire function and say return true. Because as soon as you return a value, the function stops. So I'm going to say stop right there, return the value. I know the game, whoa, check completed. I wrote false, or I said false and I wrote true. We want to say false. The game is not over. There are still letters to be guessed, so return false, stop. However, if you get to the end of the for loop ends. That's what this line is delineating here. It's saying here's stuff inside the loop, but if we check every single item in this and none are asterisks, that means that we've guessed every letter. So we return true. Okay, so that just returns true or false based on whether the Hangman word local has any asterisks left. All right, so it takes in the list as the Hangman word local. So this is a list, and it prints all of the letters in a single word with no spaces, commas, or quotes between. So, right, if you just print, I don't want to do it right now, but if you just print like some list, it'll end up looking like this. It'll be like quote, W, quote, comma, quote, O, quote, and it'll look all junky. We want to just type the actual word with none of that junk. So there's a couple ways to do it. I think the easiest, if you're being, super easy, this is just a print statement. And in here, you, with nothing, you dot join the, so when you put a empty quote here, this is the space that you want between. You can put a space in between, a space in between if you want. But this is an easy one. So this is saying, I want you to join in terms of a string. This is a string. So dot, you're calling on a string method, so a method of the string class, and then you're passing in a list. And what that does, it takes each item and it concatenates it with this as the spacer. And so it would be letter with no spacer, letter with no spacer, and it would join them all together. I'm going to do that item by item. So what I'm going to do is I'm going to build a word. Let's call this the word builder. And let's start it as nothing. And then we're going to go for letter in, and then I want to copy this. So for letter in here, then what we're going to do is we're going to go word builder plus equals the letter. So what that's saying is go through the list. So, right, there's an automated for loop. Again, not the slots, but the actual items. And each one, add it to this and save it. Plus equals, remember, is the same thing as saying, oops, let's delete it. We'll just say this is the same thing as equals word builder plus letter. That's the same thing as just shortening it and saying add and save. So add this and save the value. And then at the end, because this is a print statement, it's not saying return, it's actually saying print. So at the end, after the for loop, then we print word builder. All right, so there's our functions. These are getting really straightforward, couple lines each. So this chooses a random thing from the list and returns it. This just says yes or no, have they won? This just says, where are you at right now? Let's print it to the screen, but not with all that extra junk. Here's split word into list. Okay, so the most direct way to do this is we're going to return a list of letters. So if this comes in as like, say, right, like happy, we return a list of H, comma, A, comma, P, comma, P, comma, Y. That's a fun rhythm there. Okay, so the easiest way to do this is go return and then just the list of, and you pass this in, right? That's what this list in parentheses does. It splits it by letter, any string by letter into a list. Okay, we're going to do it a little slower. So instead what we're going to say is, here's a list builder that starts as an empty list. And then what we're going to do is for letter in that string, again, a for loop will iterate over, taking each character of the string one at a time. And then I want to do list builder. Now you could do plus equals in brackets letter. That's the same thing. You're just adding a list to it, and you can concatenate list plus list. Just makes a bigger list. However, instead, let's use the list method dot append, which adds something to the end of a list. So we start with an empty list, and one by one, we add each letter to the list. And in the end, we need to return this list that we built. So we're going to return list builder. All right. We've only got 2 left. The asterisks, the Hangman art, I'll just describe, but they'll actually pause the video while I do it because that'll take a lot of time. Just copy and paste and adjust. Okay. So now for replace asterisks in list, this is the one where you need 3 things. Okay. Now, the Hangman word local, that's a copy of, or the memory address of, the actual list where you're guessing the letters. So this is star, 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 star. And you're saying, oh, is there a P? And maybe one of those stars turns to a P. But for you to know if there was a P, to make that change, you also have to have the answer, right? And you have to have the letter you're guessing to check the answer key. So you have the answer key and the letter to do the checking. You search for that letter in the answer key. And then if you find it, you change that slot number of the Hangman word local. That's the key. So you're actually checking the guess against the answer key that's kept secret from the player, but you're making the visual change in the Hangman word local. So all of the searching is done, 1, by slot number. That's important. You need to know you're searching by slot number because you need to know which slot to change. But 2 is you need to know you're checking in Hangman word local. So we can go for slot in, and then this is, I'm even going to go slot num, so you're really clear, slot num in range length of, and it doesn't matter, these 2 lists have the same length, but since I'm searching this one, that's the one I'm going to put in here just for clarity. Okay, now this cycles through all of the slot numbers. It does not cycle through the items. So then in here, I have to say if from that list, it's slot num we're looking at right now, right? Which will start looking at 0, then 1, then 2, then so on and so forth. If the item in that slot number of this list is equal to the guess we are looking for, then, and here's where we don't make a change in the answer key because that wouldn't do anything. The letter's already in the answer key. Then, from Hangman word local, that slot number, we set it equal to the guess local. So we are updating the Hangman word local. Now, because this is not a primitive data type, when you pass a list into a function, since it's an object, what actually basically gets passed in is the memory address. So any change you make to that list really changes the original list, unless you say list equals something else, because then what you're doing is you're taking the arrow that used to point at some address, like point at that house over there, and instead you're saying actually point it over here. So now the changes you make are at a totally different house. But if you don't do that, then any list that comes in, you go, oh yeah, it's pointing at that address over there. If we paint that house, the original house is painted. If we break a window, the original house's window is now broken because all I'm doing is pointing at an address and we are making real changes to that house at that address. Okay. All right, so draw Hangman art. All I'm going to do is something simple here. I'm just going to say if the number of guesses coming in is equal to 0. Oh no, we said 0 is death. So we're going to say if they're 1. If they're dead, we're not going to print the sign. We're going to say you lose, goodbye or something. But if we're still in the game, we're going to print the ASCII art. Then what I want to do is just print something. Now it's going to be a multi-line picture. And so I'm just going to write picture here. And then I'm going to have to figure out like where I'm going to get a picture. And then essentially what I'm going to do is I'm going to do the same thing, but with an elif. I could do if because it's really clear, but I'm not going to do if. Oh, dang. I hit random buttons. Okay. So I'm going to do paste. Come on. Oh, come on. There we go. And so I'm going to do an elif, and then I'll do that same thing. Okay, I'll put it right here. That's, I don't know, so 2, 3, 4, 5, however many you want to do. Okay, so I'll do elif, it's 2, elif it's 3, elif it's 4, elif it's 5, elif it's 6. I don't know how many guesses you want to do. I'll say 7. I don't know. That sounds good to me. And then what I'm going to do is I'm going to open a new tab, and I'm just going to Google like ASCII art. Okay? And there's an ASCII art archive, and I'm just going to find something fun. I don't know. Let's look at cartoons. Casper, Betty Boop, Looney Tunes, Mickey Mouse. Oh, these are good. Oh, let's look at some Simpsons. That's good. Okay. Look at this. Okay, so how many lines is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's pretty close right there, but that was a pretty good one. But what I'm going to do is essentially just print one line at a time. Oh, the whole family. Oh, that's so many. That's so many hairlines. But we could do like, I could just print like 2 of these at a time until it's the whole family. Nah, let's not do the Simpsons. This is good. Okay, well, I'll leave you here. I'm just going to find something fun to draw. But then I'm just going to print pieces of it until there's a whole picture. Okay? I'll put that in, and then I'll post this link to the video. All right, guys. Hope you enjoyed.